Yes, my dear friends, audible na? Yes, audible. Just 1 second. Yes, okay. Very good evening to all. Am I audible, visible? Everything is perfect now? Yes, I think everything is perfect. Okay. So, yes, very good evening to all. So, my dear friends, today I am going to be see, what different type of question we can expect in Coal India Limited. And that is the session on the strength of material and, either if you talk about mechanical or civil, in both the branch, at least you can expect 7 to 8 questions from the strength of material. If you see the previous year trend, if you do the analysis of PYQ, we will see at least 7, 8 or 9 question is going to ask from that segment. That's why it is very important. And yes, I will see if you see the pattern of CIL, what is the difficulty level, what type of question we can expect. So here I have taken more than 25 questions, and in all that we can see, we can just analyze okay what type of question is going to ask, and most important in less time how you will be able to solve all that question, right? So let's start, my dear friends. Everything is cleared, all you are energetic. Okay, so let's start. And before starting the session, I want to tell you, my dear friends, I will share that PDF. Okay, I will share that PDF with all of you. And there's one free WhatsApp group in which usually our team and even me, I'm going to share daily some content regarding your exam, which is free of cost, so that you could be able, analyze okay what type of question is going to ask, how much depth is required for the CIL. That's you will be able. That's why please join the our WhatsApp group. And if you have the issue, we can just scan here civil engineering group, here EC electrical CSC, and yes, this is your mechanical, right? And there is a more 661st is there, and our paid batch already started from the 13th of May, right? And we can see, and that is the big pool of the mentor of your different category. Here we can see. And yes, one more thing, do not forget to like the session, right? That is something which can you pay to us, right? So that all our mentors which will help you in different category. As I told you already, our batch is going on. Mechanical group, civil, electrical, electronics, non-technical, all are there, right? So let's start with the first question, my dear friends. And one more thing, if you talk about the strength of material, basically they are going to ask numerical question. Basically, some theoretical question will be there. Out of 8 questions you can expect 6 question is numerical, 2 question they will ask the theoretical. So overall question level you have to be keeping easy to moderate. Like that way I have framed the here question, and there are variety of question I have came with. Variety of question is there, my dear friends. As I told you, variety of question is there. I have tried to cover all the category of the strength of material, all the topic I have covered here, and what type of question we can expect by the analysis of PYQ, either you are from the civil or mechanical. And as I told you, I will share that PDF to all of you. So okay, no, I will not waste your time. Let's start with the story. That is the first question on your screen. And yes, question is that a bar of uniformly tapered, right? A bar of uniformly tapping from diameter D1 at one end to a diameter D2 at the other end is subjected to an axial tensile load P, the length of the bar L, and the Young's modulus is E, the extension of the bar. You have that option. Please answer that question on your screen. Waiting for all of you answer. What will be that question? My dear friends, suppose if you have a prismatic bar. What the meaning of prismatic? Prismatic means area of cross section is same throughout. That is the meaning of prismatic bar. And if you are going to apply the load P in case of prismatic, then what will be the deflection? Because of that load, you will get the deflection, something like that. That is your change in length, and change in length is given by PL upon AE, right? PL upon AE. But that equation is applicable only when if the bar is prismatic, load is axial. then only you are able to apply that equation. But in that question, you can clearly see that it is not a prismatic bar, it is a tapered bar, right? It is a tapered bar. Let's assume this is D1 and this is D2, and you are going to apply the load like that. Let's assume P. So same thing is there, my dear friends. Even in the class I used to discuss, if you talk about in that case, what will be PL? In case of A, it will be pi by 4 D square, right, into E. So can you write like that? P4 PL upon pi D into E. Can you write like that? Yes. It will be same here, but it will be like that, 4 PL upon pi. But here D and D is same not throughout because it was a prismatic. But here D1 and D2 is going to be changed out. So just write down here D1 and D2 into E. So that will be the, deflection in the tapered bar when you are going to apply the prismatic load. And sometimes they may ask, what is the relation between the prismatic bar and that is tapered bar? If you have to get the same elongation, so what will be the equivalent diameter? So if everything is same, we can say from there, sir, D square will be what, my dear friends? D1 and D2, right? So from there we can say D will be the geometric mean of the D1 and D2. So sometimes they will ask like that question also. If I have a tapered bar having load P, because of deflection is del 1, I want to get the same deflection in a prismatic bar, then what will be their equivalent diameter by the application of same load? So it will be the geometric mean like that they will ask. So be ready for that. But in this question, if you talk about what will be the answer, my dear friends? 4 PL upon pi E D1 and D2. Yes, A for apple is the right answer. A for apple is the right answer. And hopefully all of you have given the correct answer of that one. Good. Come to the next question. Okay. Come to the next question. That is the next question. If the radius of wire is stretched by a load is double, then its Young's modulus will be double, half, becomes 4 times, become 1/4, or none of the above. What will be answer of that question? Question number 2. Question number 2 on your screen. What about others? I am getting answer here. Answer everyone. Radius of wire stretched by a load double. You are going to be just load. You are going to be double, right? Load को आप double कर रहे हो. Then Young's modulus will be. What will be the Young's modulus? And some option is here. I am getting 2 types of answer. Someone who is going to give the answer C for Chennai. So I am going to give you one lifeline, and C for Chennai is the wrong answer. Okay, C for Chennai is the wrong answer. That is just a lifeline to all of you. So Kumari is telling E for elephant. So yes, my dear friends, elephant is the right answer. Very first class I used to say, if you think about the strength of material, what is the assumption? Throughout the strength of material, Hooke's law is applicable. That is, stress is proportional to a strain, right? Stress is proportional to a strain. And if you are going to remove the proportionality, then you are getting something E, Young's modulus of elasticity, known as this is proportionality constant. So my dear friends, if you are going to be double the stress, then strain will be the change. But E is the material property, my dear friends. It will change only when if temperature is going to be changed. Temperature is changed, then only you can change the Young's modulus of elasticity. It will not going to be changed by the application of load, by the application of any times of pressure, by the application of thermal stress. It is not going to be changed at any all. In any case, it will not change. It will change only when if I increase the temperature beyond a limit. So correct answer will be E for elephant. And good thing is that most of you have given the correct answer. That question several times has been asked, and sometimes the student going to be answer B, sometimes A, sometimes C, like that they have given. So always keep in mind, E, G and K is the property of material. That is not going to depend on the application of load, and that may change by the application of only temperature. Otherwise it will remain constant. Here we can say only the load has been double. So if stress is double, strain will be double. Rest thing will be the same. And hopefully you all have given the E for apple, E for elephant is the right answer. Come to the next question. Okay, one question was from that relation, Poisson ratio. One question always going to ask in the exam, and they are going to ask usually numerical. That's why I have come with that question. The question is that the Young's modulus of elasticity of a material is 2.5 times of its modulus of rigidity. Okay, then the Poisson ratio for the material will be, and you have some option. What will be answer? And yes, do not forget, like, share the session with your friend also. Right? So what will be answer? Tell me everyone. Waiting for your answer, my dear friends. So Alak Fande, yes, he is going E for Delhi, okay, D for Delhi. What about others? My dear friends, always keep in mind, one question we will expect, obviously, from the elastic constant relationship. Always in all exam, they are going to ask one question from the relation of elastic constant. So what the relation these are, my dear friends? So I am going to tell you here. First relation, E is equal to 2G into 1 plus mu. Mu is called Poisson ratio. E is equal to 3K into 1 minus 2 mu. And E is equal to, as I used to say, 9kg upon 3K plus G. 3K plus G. From that three relation, one question we will expect. Try to remember. E is equal to 2G into 1 plus mu. E equal to 3K, 1 minus 2 mu. E equal to 9kg, 3K plus G. That from that we'll get one question. Now, how I can remember, sir? E is equal to 2G. You know, 2G is a slow speed. So you have to be add, because in the option you can get minus also. So always keep in mind, 2G is a small speed, very small speed. You have remember 10 years ago, speed was 2G for the internet. It was very less. So you have to be add 2G into 1 plus mu. Okay, 3K. So K is higher value. That means you have to be minus 1 minus 2 mu. Here 2 was there, then here 1 is there. Here 3 is there, here 2 is there. Keep in mind. Okay. Now E is equal to 9 kg. You are going to purchase the mango. You used to say, give me 5 kg of mango, 10 kg of mango. So 9 kg, 3K plus G, not 3G or plus K, 3K plus G. Now, by using that, give the answer of that question. By using that, answer that question. What will be the answer? In the Young's modulus of elasticity of material, E is given how much, my dear friends? 2.5 times of G. Okay, modulus of rigidity, the Poisson ratio. Then you have to be calculate the mu. So what relation you have to be used, my dear friends, in that question? E is equal to, my dear friends, what will be? We can say, sir, 2G into 1 plus mu, right? And E is equal to what, my dear friends? Simple question it was, simple numerical. E is equal to 2.5G, right? Is equal to what? You can say 2G into 1 plus mu. क्या यहाँ से mu का value नहीं निकाल लोगे क्या? Can you get the value of mu from there? Yes, sir. Easily I am able to get the value. And how much it is coming out to be? By solving that, we can say, sir, these two, here is equal to 2.5G. GG will going to be cancelled out, and I will get the value of mu. Let me check how much its value is coming out to be. By solving that, how much it is coming out to be? Yes, D for Delhi is the right answer. So my dear friends, isko P जाओ. That equation P जाओ. Anyhow, we will expect one question from that. तो इसको P जाओ आज, ठीक है? पीना मतलब P जाओ, है ना? तो हम देखेंगे और भी क्वेश्चन इस पे in the next session. Okay, that was from the elastic constant. Now next question on your screen. The question is that the elongation of a freely hanging uniform steel rope, right? If its length is double, will increase in the ratio of hanging rod. You have one of the steel rod which is going to be hang like that. Okay, it is going to be hang like that. So can you get deflection in that? Yes, sir. Why, sir? Because they have some weight, na, sir. Because of the weight, it will get deflected. Now another question, their length is L. Now the scenario is that same is there. Now I am going to make it L, 2L. Then what will be the reflection? That thing is going to be asked. What will be answer? Everyone have to be answered here. Everyone have to answer. So can you tell me in that case? Okay, tell me like that way now. In that way, like the P is going to be applied like that. So what will be the deflection? What will be the change in length? Change in length we can say, sir, PL upon AE, right? PL upon AE. So sir, suppose if W is going to be that, can I write change in length equal to WL upon AE? WL upon AE, can I write? Yes or no? Never. Never make a mistake like that. Usually a student is going to be make a mistake like that. They think, okay, net load is W is going to be act, so it will be WL upon AE. But my dear friends, that is totally wrong. We can ask, why, sir? Why this is wrong? My dear friends, if you see that diagram, in this, everywhere P is there. Everywhere P is there. Everywhere P load is going to be act. Everywhere. हर जगह P लग रहा है. But if you talk about in that case, my dear friends, W is not same throughout. Here will be something different value. Because अगर तुम यहाँ से काट दो, the W की value will be something different. If you see from there, the W will be only for that weight. If you see from there, it will be only for that. सो सर यहाँ पे W चेंज हो रहा है सर, ये तभी था ना जब P कांस्टेंट था सर, बट हियर W इज गोइंग टू बी चेंज ना सर, सो कैन आई राइट लाइक दैट? नो सर, नो आई कैन नॉट लाइक दैट, ऐसे हम नहीं लिख सकते हैं. So what will be the deflection in that case? Always keep in mind, in the class I used to prove that this is given by change in length is always given by rho g L square upon 2e. Always keep in mind rho g L square upon 2e. Rho g L square upon 2e. So only we can say in this length is only going to be changed. So we can say change in length is proportional to length ka square. Now can you get the value? Now can you get the value? Yes sir. So put that value, and by solving that, how much you are getting? You are getting the relation. Just put that value. We can say sir, change in length upon L square is equal to constant. So can I say change in length L1 upon L1 square is equal to change in length in case of 2 upon L2 square. And what is the value of L2? L2 is equal to twice of L1. Just put the value, and by solving that, the relation is coming out to be 4:1. 4:1. Okay, one more thing I want to tell you here. Can you tell me stress is going to be depends on the material property? Yes or no? Tell me, stress is going to be depends on the material property. What do you think? Suppose, usually I used to tell, suppose this is the gold, right? And this is your silver having same cross section. This is your silver. You are going to apply P, and you are going to apply P having cross sectional area A, having A. What will be a stress in both the case? We can say sir P upon A, here also P upon A. But this stress is going to depends on the material property. Even this is gold, stress still the stress is P upon A. यहाँ पे सिल्वर है, यहाँ पे भी आप देखोगे stress is P upon A. So in even material is different, but in the both the case you are getting the same stress. It is not going to depends upon the, we can say, property of material. It is just going to depends upon the what you can say apply load, and you can say geometrical quantity. Now let's assume another thing. Now this is the gold, right, having length L. This is your gold having length L, and this is your silver. This is your silver having length L. Now tell me, in both the case, do you get the same stress? Do you get the same stress? No sir. So always keep in mind, stress due to self weight is going to be depends on the property of material, but this stress never going to depends upon the property of material, but stress due to the self weight and stress due to the thermal stress. If you talk about what is stress in thermal, what is the thermal stress? Anyone have? E alpha delta T, right? E alpha delta T. So in whole strength of material, keep in mind only two stress is there, which is going to be depends on the property of material. Only two stress. Which one? One is the stress due to self weight, and another one is the thermal stress, which is equal to E alpha delta 2. Other than that, whatever stress you talk, that is just a geometrical quantity. It is not going to be depends on the material. So keep in mind that type of question they may ask in your exam. So only these two stress is a material property, but here you talk about it is not going to depends upon the property of material. So in the what test series, I have added that question. So it will be important to you to join the test series also, because I have taken all different types of question there. That is the next question on your screen. That is the next question on your screen. The tensile stress as a point across the two mutually perpendicular plane are 120 megapascal and 60 megapascal. Okay. The normal stress on a plane inclined at 30 degree to the axis of the minor axis, and this you have some option. What will be answer, my dear friends? What is the scenario of that question? Try to solve. I am going to tell you. Suppose this is one. This is proper visible, na, my dear friends? This is like that. Scenario is something like that, my dear friends. Okay. Okay, sir. Like that. And if you think about like that, the condition is something like that. Okay. Now you have this is and you have a one plane like that. Okay. Now I am going to apply the P there. So what will be a stress on that plane? What will be a stress on that plane? We can say, sir, on that plane stress will be P upon A. Okay. But now I will ask, what will be stress on that oblique plane, my dear friends? Now, what will be stress on that plane? Tell me, what will be stress on that plane? It will be P upon A, same value? No, sir. This is for that only, na, sir? हाँ सर, दिस इज फॉर ओनली दैट. यहां पे तो हमें P अपॉन A आएगा, लेकिन अगर मैं पूछूं इस प्लेन पे बताओ व्हाट विल बी द स्ट्रेस, एंड यू नो माय डियर फ्रेंड्स, दैट्स व्हाई आई एम गोइंग टू बी रीड अबाउट द मोर सर्कल. यही कहलाता है, दिस इज कॉल्ड ऑब्लिक प्लेन. ओके, व्हाट? ऑब्लिक plane, and this angle is what? 30 degree. So what is the formula for that? Anyone have remember what is the formula for that, my dear friends, to oblique plane? I am going to give that formula and you have to remember at least till the exam. Okay, normal stress on oblique plane is given by, always keep in mind, my dear friends, normal stress on oblique plane is given by half of sigma x plus sigma y plus half of sigma x minus sigma y cos of 2 theta, and plus if any shear stress is there, plus tau xy sin 2 theta. But okay, in this question, since no shear stress was there, I have removed. So please remember that formula. Yes, in the classroom I will prove, but right now just remember, normal stress on oblique plane is given by half of sigma x plus sigma y plus half of sigma x minus sigma y cos 2 theta plus of tau xy sin 2 theta. Since in the question no shear stress is there, I am going to put that value 0. So my dear friends, we can see here in this question, sigma x is given, sigma y is given, and you have to be calculate at a 30 degree, right? So what will be the normal stress on that plane? Just put the value sigma x, sigma y. So just put the value, and you know cos 2 theta. So cos 30 plus 2 theta cos 60 will be there. So cos 60 and cos 60, you know, it is half. So 90 plus of that value you are going to be get, and by that you will getting 105. Now I will ask, what will be the shear stress? Now tell me, what will be the shear stress on oblique plane? Anybody can tell me? They may ask, what will be shear stress on the same question? Shear stress on oblique plane. On oblique plane. Anybody can tell me? In the same question I am going to ask, what will be shear stress on the oblique plane? देखो, इस प्लेन पे तो आपने नॉर्मल स्ट्रेस निकाल दिया देशवासियों, इस प्लेन पे तो आपने नॉर्मल स्ट्रेस निकाल दिया भाई. आपने बोला कि सर नॉर्मल स्ट्रेस ये है सर, बट नाउ माय क्वेश्चन इज दैट व्हाट विल बी शियर स्ट्रेस ऑन दैट प्लेन बाबा, व्हाट विल बी द शियर स्ट्रेस ऑन दैट प्लेन? सो नाउ यू हैव टू बी मेक कमेंट अबाउट दैट, you have to be make comment about that shear stress on the oblique plane. Okay, well now meanwhile now I am moving to the next question. So ये सारा आपको याद रखना है दोस्त, सारा याद रखना है, और टेस्ट सीरीज में क्लास में आई विल डिस्कस ऑल दैट. ओके सर, दैट इज द नेक्स्ट क्वेश्चन. द स्टेट ऑफ स्ट्रेस एट अ पॉइंट अंडर प्लेन स्ट्रेस कंडीशन. व्हाट इज द मीनिंग ऑफ प्लेन स्ट्रेस सर? Sir, what is the meaning of plane stress? First tell me, what is the meaning of plane stress? Babu, you know plane. So plane में क्या होगा बताओ? Only 2D case, right? This is board is my plane, Baba. Board is what? My plane. So plane, this is x-axis and this is y-axis. So whenever you talk about the plane, na, always keep in mind only two stress will be there. If you talk about a space, अगर मैं board के perpendicular आ जाऊं, if I am going to apply the load perpendicular to the board, this will be called a space. और यहां पे हमारे पास 3 स्ट्रेस आ जाएगा. बट हियर क्वेश्चन क्लियरली इट इज टेलिंग दैट कि सर इट इज अ प्लेन स्ट्रेस, मींस ओनली 2 स्ट्रेस इज गोइंग टू बी एक्ट देयर. ओके, सो हियर गिवन सिग्मा एक्स एक्स एंड सिग्मा वाई tau xy is given. Usual meaning the radius of Mohr circle representing is given the stress. What will be the radius of Mohr circle? Answer now fast. I am waiting for answer. You have just 1 second of time. Yes. What answer is coming out to be 60? What about others? Please remember, yaar, all that, huh? All that, na? What is the radius of Mohr circle? Okay, so we can say root under of sigma x minus sigma y by 2 whole square plus of tau xy square. That is called radius of Mohr circle. So in the question, everything is given. It was easy question. So yeah, some easy question is also going to be asked. That is little bit calculation, but question is easy. Sigma x is known, sigma y is known, tau xy is known. Just put the value, and by putting that, we'll get the Mohr circle, whatever value is coming out to be from there. How much it is coming out to be? Everyone have to be answer, yaar. Only few student is going to be answer. Abhishek and all. What will be the value? Yes. By doing that, what value it is coming out to be? What? 50 is the right answer. So yes, keep in mind that formula also. Radius they will ask. What will be center of Mohr circle? Now I will tell you to draw Mohr circle for that. Okay. Now my question to you, draw Mohr circle for that scenario. Draw Mohr circle for that. Now my question to all of you, draw the Mohr circle. You know, my dear friends, for making a circle, how much information you needed? I want to tell you, okay, draw circle. How much minimum information you need to draw a circle? First, sir, give the center. What is the coordinate of the center? And second thing, sir, what is the radius? If you give these two information, radius and center, I will draw the Mohr circle. So what is the center, my dear friends? Center will be always sigma x plus sigma y by 2 into 0. So what is sigma? So 40. And what is this? 100 upon 240. So 140, that means center will be the 70 and 0. 70 and 0, and radius you have calculated. So how we can draw the Mohr circle? Okay, so this is like that. Center is what? 70. So this is 70, and radius is what? 50. So it will be something like that. Okay, note that they will not touch exactly to that, because this is like that now. Like that. We'll get that way of Mohr circle of that case. ठीक है ना? तो इन दैट वे विल गेट द रेडियस. और देखो यही तो तुम्हारा रेडियस है, नहीं है क्या? ये 50 है, एंड विल गेट दैट. So when they will ask what will be the center coordinate, what will be the radius, draw the Mohr circle, all you must have to be know in that case. Okay, sir, come to the next question. That is the good question, my dear friends. A cantilever beam is loaded as shown here. Okay, which of the following Mohr circle shown here represent the stress element at point A? And I am going to be little bit zoom out. Okay, and you have the option like that. You have the option like that. What will be answer? What will be answer of that question? Tell me. A, B, C, D. This is the cantilever beam you have, and you are going to apply the load F at the free end, right? So you have to be calculate the what will be the stress at a point A. Who can answer that question? Who can answer that question? Waiting for answer. That's a challenge to all of you. Tell me who can say the answer of that. Let me check. जिसने भी सही आंसर बता दिया, will get thanks from my end. So Abhishek and Alak, everyone is going with option A, and I am going to give you one lifeline. Option A for apple is the wrong answer. Option A for apple is the wrong answer. Now what will be the next? What will be the next? Okay, now a student had shift to option C for Chennai. Now option I am getting C for Chennai. My dear friends, C for Chennai is also long answer. Up दो lifeline you have already used, and only one lifeline is left. After that question का answer आ जाएगा. So now only one lifeline is left, right? Two lifeline you have wasted. One lifeline is left. Tell me what will be answer? What will be the answer? Okay, do you want one more lifeline? Okay, let us do. So another lifeline, I am getting answer B for Bombay, and unfortunate B for Bombay is also the wrong answer. B for Bombay is also the wrong answer. Then what could be the answer? Yes, my dear friends, D for Delhi. So do you think, sir, because all the questions is not easy, my dear friends. If I have to be get selected, my score must be 160 plus. If you want to be in the safe zone, out of 200, your score must be 160 plus, my dear friends. Then only you can save yourself in the safe zone, right? So in that type of some difficult question will come. So you must have to be solve difficult question also. Do not think, sir, I will solve only easy and moderate question and leave the difficult one. That leads to your rejection, my dear friends. That's why, please, if that type of question is coming, take it positive. No need to escape, yaar. Alak, no need to escape. Out of 200 question, only we can escape 30 question, not more than that. 100 technical, 100 non-technical. Otherwise, आप भी escape हो जाओगे selection से. Right? So no need to escape. Okay. So my dear friends, listen. Sir, what will be the scenario, sir? Correct answer is what? D for Delhi is the right answer. Now tell me first thing that I want to ask. If you are going to be, listen, like that. No, I'm going to be zoom. No, I'm going to be zoom. So that should be more visible to you guys. Okay. So the scenario is something like that. Okay. If you are going to be apply the load like that, dear. So what will happen? What will happen? We can say, sir, it will be something like that, sir. Okay. I'm going to change the color. It will be something like that, sir. Yes, sir. It will be the something like that, sir. Yes, sir. Am I right or no? Yes, sir. It will be something like that, no, sir. It will be something like that. Now, my question to all of you, tell me, you can say the upper fiber in the compression and below fiber, this is in the tension, right? And upper fiber in the compression. Yes, sir. Upper fiber in the compression. Now, sir, if upper fiber in the compression and down fiber in the tension, yes, magnitude will have same, sir, but it will be the compression, right? And sigma y we are not getting. So compression means what? Negative. So that was just a hint, my dear friends. Negative. So their center will be in the negative direction. Their center. Here you see, do not think you have to be calculate there. You have to be calculate at the upper part. You have to be calculate only at the upper part. I have to be calculate here more circle, not for the down part. So at the upper part, only one stress is there, sir. Sigma x is there, and this is negative in the nature. Yes, there is also, but it is positive in the nature. But I have to be calculate at the upper part only. And sir, you know, just you have told, sir, center will be sigma x plus sigma y by 2 into 0. So sigma y is not there, sir. Only sigma x is there, sir. So sigma x is what? Negative. So I will get the negative. And now go through the option, my dear friends. Now go through the option. Only one option was there in which you are getting the negative center. Negative center. And easily you will be able to answer. Easily you are able to answer. Yes. And yes, right. Only you are going to answer. Rest will get the shear stress also, my dear friends. In that case, we'll get the shear stress also. So here you are getting the shear stress also in different plane. Simple was there. Yes, I will see more question. I will give that type of more question in the test series. Why? Because you have to be always keep in mind 160 plus you have to do. And you don't have to be skip that type of question. And yes, I have given the explanation. Okay, if not suppose, if they will ask in the bottom fiber, in the same question, they will ask on the bottom fiber, then what will be the answer? In that case, A will be the answer. In the bottom fiber, A will be the answer. In the top fiber, D will be the answer. B and C never will be the answer. Hopefully that thing is clear to all of you, right? I have given everything explanation there. Okay, that is the next question on your screen. Answer that question. Bending moment and torque T is applied on a solid circular shaft if the maximum bending moment stress is equal to maximum shear stress developed, the M is equal to, and you have some option. Answer that question. Yes, answer that question fast. What will be answer of that? What will be answer, yaar? Yes, आशीष, it will be mention, यार. ए जो है ना ऊपर में है, देखो ये पूछ रहा है सर ये मेंशन है क्या? हाँ भाई साहब, ये ए वाला पॉइंट ऊपर है ना? ये पूरा देखो दिख रहा है ना? तुम्हें दिखा रहा है कि ऊपर वाला पार्ट में पूछना है. That should be mentioned more मतलब clearly should be mentioned. Otherwise it will be mentioned, right? It should be more clear कि on the top fiber like that. Yes, so bending moment time torque T applied to a solid circular shaft. Maximum bending moment is what, my dear friends? Have you remember maximum bending moment? 32 m upon pi dq, right? And if I talk about what is the bending stress is equal to maximum shear stress. What is the maximum shear stress? Anyone have remember? 16 t upon pi dq. Always in the class I used to solve that question. Now the question is that maximum shear stress developed. Okay, what is the question? The maximum bending stress is equal to, so sigma b is equal to tau max. This is also maximum. Now just to equal 32m upon pi dq is equal to what? 16t upon pi dq, right? So pi dq will cancel out. M will be equal to t by 2. M will be equal to t by 2, right? 16 2 ja t by 2. A for apple is the right answer. Only few students have given the answer. So see your preparation level, my dear friends. Don't think I will skip all that type of question. Really, I am telling you, selection will skip you. If you skip all that of question, what will happen? Selection will also skip you. Okay? We'll try in the next upcoming COL exam. Well, so that was another easy question, but yes, you must have to be remember. That is another question on your screen. The moment diagram for a cantilever beam whose free end subjected to a bending movement, and you have some option. What will be answer? Answer everyone. And yes, do not forget, my dear friends, to like the session also. What will be answer of that? Do not skip. No. What will be answer? Rectangular Bombay. Okay. Now you have terminology, sir. No, sir. That time I will not skip a question, and I will not allow COL India to skip my selection. Right? COL India have to accept my selection, right? Yes, no need to skip any question. Any question. Your attention should be solve all the questions. Rectangular, sir. Yes, my dear. See. Diagram of a cantilever beam, right, Baba? So this is your cantilever beam. Cantilever, you know, na? Free end subjected to a bending moment. Okay, directly you are going to apply the something like a bending moment M. Okay, like that you have just given anti-clockwise. Okay, so what will be the reaction? It will be the clockwise, right? What will be the reaction? It will be anti-clockwise. Reaction will be the clockwise. No, and it will be same throughout. Same throughout, na? Jahan bhi dekho, it will be same. So we'll get the positive, clockwise is positive, we'll get like that. But if the scenario is something like that, this, and you are going to apply like that, this is your M, then in that case, it will be negative bending moment, okay? In that case, we'll get like that. This is 0, so negative, here you will get the positive, and yes, it will be rectangular. So that time, all of you have given the correct answer. Okay, good. That time, every one of you have given the correct answer. B for Bombay is the right answer. Come to the next question. Yes, sir. Question is that the given figure shows the shear force diagram for a beam ABCD. Bending moment in the portion BC of the beam is, and some option you have. What will be answer? Need to escape? Need to escape? Tell me. No, sir. Yes, then what will be answer? Alak Pandey. Alak Pandey is going to answer what? 0. And Alak Pandey, your answer is absolute wrong. So one lifeline you have usage. What about others? Arvind is telling B for Bombay. Value linearly from B to C. So another lifeline you have used, B for Bombay, is again wrong answer. What about others? No, only 2 options is left. My dear friends, do not make a mistake now. What I have in the today class I taught you. Yeah, have you remember? So this is what? Bending moment diagram of a portion BC of the beam. The given figure shows the shear force diagram, Babu. So BC, shear force is 0, na? Shear force is 0, right? So you know what is the shear force, sir? Shear force is dm upon dx, right? Yes, sir. Dm upon dx. So shear force is 0. The meaning is that m is constant. Am I right or not? Tell me, yaar. Shear in the BC section, shear force is 0. So if shear force is 0, the meaning is that m is constant, sir. If I differentiate, tell me d5 upon dx is what? 0, na, sir. If you differentiate constant things, we'll get the 0. That means, sir, m is something constant. It is not going to be vary. It is something constant, sir. So now see the option. A will not be, B will not be. Parabolic. Oh, sir. Parabolic will be only when if it is linear, sir. But it is 0, na, sir. So Chennai cannot be answer. What will be the answer? यही देखो बता रहा है, मालिक आते हुए क्वेश्चन गलत होता है, तो इसी को तो ठीक करना है जी, है कि नहीं? इसी को तो ठीक करना है. That need to be improved. So is a non-zero constant is the right answer, because in this segment shear force is 0, meaning is that bending moment will be the maximum and yes, constant. So okay, most of you have given the wrong answer. Yes, few of you have given D for Delhi, right answer. Okay, sir, come to the next question. I think that question all of you can answer. The bending moment diagram of the beam shown in the figure will be, what will be the bending moment diagram for that case? What will be bending moment diagram for that case? Answer everyone. What will be bending moment for that case? Need to answer everyone, dear. Very simple question now. What will be the bending moment? Simple question. Huh? What will be moment about? So this is W. It is going to be act. Simple, we can say na. So shear force is what? Yes, what answer I am getting? Triangle, triangle, triangle. Okay. Someone is D for Delhi. Parabolic. हाँ? क्लास करो जी, क्लास करना जरूरी है, समझ रहे हो? Need to more attention. Really I am telling you. हाँ? क्या हो जाएगा इसका आंसर बताओ? Let's assume this is at a distance L by 2. Let's assume this is L by 2. So what will be the reaction? It will be W by 2. It will be W by 2. Right? What will be the bending moment about x-axis? So bending moment about x-axis will be the W by 2 into x. And what is the variation with x, my dear friends? That is, you can say the linear, right? That will be what? It will be the linear. So rectangle, triangle. Yes. Given, you have given answer is what, my dear friends? B for Bombay is the right answer. This is, even you can draw the shear force diagram and we will get their corresponding bending moment. Yes, Alak Pandey, that time you are right. देखो हमेशा मैं पढ़ाता हूँ SFD BMD में ना, if you have to draw the shear force diagram, what will be their shear force diagram? Tell me. If I will ask, what will be their shear force? Shear force क्या हो जाएगा बताओ? What will be their shear force? Anybody can tell me what will be the shear force? Huh? Like that, na? Sir, like that. So this is 0, sir. Let's assume 0 line. So shear force W by 2 is upward, W by 2 upward, W downward, and again this will be the shear force. Now see, we can see, so shear force. Now try to draw their bending moment diagram. Just see the diagram and comment about the bending moment. So we can say, sir, this is 0. So sir, now you think about here. If you are going to take about moment about x-axis, what will be? W by 2 into x, W by 2. If you are going to put the x equal to 0, bending moment will be the 0, right? And whenever shear force is 0, bending moment will be the maximum. And here we can say this is slope, this is constant, na baba. This is constant. Here we can say shear force is constant. That means slope of bending moment should be constant. And when it will be the constant, sir? When it will be constant? When it will be something like that, sir. Their slope is constant, sir. Their slope is constant, and the slope of bending moment shows the shear force. So if you are going to see A, B, C, so here you say A, B, and C. So in the A, B, shear force is constant. Here we can say slope of bending moment is constant. Same here, and you can say shear force is positive. So slope is positive. Here we can see in that case shear force is negative. So slope will be something negative. Slope will be negative. What is the meaning of positive slope? Now you can confuse. My dear friends, whenever you talk about this is x, this is, let's assume, just today I have taught you, this is y, this is x, right? This, if x increases, y increases. The meaning is that this is positive slope. This is positive slope. And this is like that, my dear friend. This is y, this is x. Here we can say x increases, y decreases. The meaning is that negative slope, Baba. The meaning is that negative slope. And you know, slope of bending moment shows the shear force. So here we can say negative. And here, even in that section, I can say, sir, bending shear force is negative. So their slope is negative. And yes, sir, it is a constant. So their slope is constant everywhere. So what is the fault is there? Even they will ask any type of question, easily I will be able to answer. Right or no? Everyone have concept the clear? This clear concept? Okay, don't worry. We'll see in more class. In upcoming class, I will see all that. Don't worry. Now that is the another question on your screen. Question is that circumferential and longitudinal strain in a cylindrical boiler under internal steam pressure are epsilon 1 and epsilon 2 respectively. Okay, change in volume of the boiler cylinder per unit volume will be, and you have some option. Answer everyone. Answer everyone. What will be answer? Not getting answer, dear. Huh? Circumference, you know, this is one of the boiler like that. Huh? So my dear friends, this is scenario, na? Okay. So in the boiler, you know, whenever some steam is there, so steam will exert pressure like that. Kala kala steam hai. So this will exert a pressure like that. कोई steam है ना बाबा, तो pressure ऐसे लगेगा, बिल्कुल लगेगा सर. और pressure ऐसे भी लगेगा सर. It will be something like that also, sir. Yes, sir. It will be something like that also, sir. है ना, बंद है ना भाई. Okay, sir. Boiler cell है ना. Okay. So now you know this, because of that, whatever stress will generate, this is called circumferential or hoop stress. This is act on a circumference. That's why it is called circumferential stress. And this act upon the what? Longitudinal axis. So this is called longitudinal stress. Longitudinal stress. Now always keep in mind, my dear friends, hoop stress will try to increase the diameter. They will try to increase the diameter and reduce the length. But if you talk about longitudinal, they will try to expand the length. They will try to increase the length. Right. Now, sir, one more thing here. In this question clearly mentioned circumferential and longitudinal. So circumferential is given strain, sir. Strain is given. This is circumferential strain. And sir, epsilon 2 is the hoop, you can say the longitudinal strain. So what will be the answer, my dear friends? What will be the volume of that? What will be the volume? So we can say, sir, pi by 4 d squared into L, right? So if you are take ln both sides, ln v is equal to ln pi by 4 d squared plus of ln L, right? Yes, sir. So what will be ln v? Ln v will be 2 ln pi by 4 d plus of ln L, right? Now do one thing, differentiate both sides. So what will be the volumetric strain? dV upon v, it will be 2. And this will be what? Change in diameter upon original diameter. This is d change in diameter upon original. So this will be the 2 epsilon 1. And this is dl upon L. If you integrate dl upon L, so this is longitudinal. So epsilon 1. So answer will be here 2 epsilon 1 plus epsilon 2 plus epsilon 1. So what answer you are getting? 2 epsilon 1 plus Chennai. Chennai is the right answer. Good. All of you have given the right answer. So अगर ऐसा कभी भी question they are going to be asked, right? No, comment answer in case of sphere. ये तो सिलेंडर का था. अगर मैं आपको स्पेयर में पूछूं तब क्या हो जाएगा? तब क्या हो जाएगा बताओ? स्पेयर में will get the volumetric strain 3 times of epsilon. Yes, right. So even whatever they are going to be asked, easily I am able to calculate. Good. Yes, you guys are really fantastic now. तुम्हें पता था यार, तुम बहुत समझदार हो. हाँ, इतना समझदारी कहां से लाते हो? तुम पहले से कमेंट करके रखा था. Now, hoop stress of a thin cylinder diameter d and thickness t subjected to pressure p. Yes, some easy question like that they will ask. है ना? All they will not ask moderate or difficult. Some easy will be there. So what will be answer of that? Hoop stress na. So what will be the hoop stress? Hoop stress is going to be act on the circumference. That's why it is called circumferential stress. Some fluid will be there. In that some fluid will be there, and this fluid will exert pressure on the wall. Wall पे pressure लगाएगा, circumference पे लगाएगा. इसी को हम hoop stress बोलते हैं. और hoop stress क्या होता है बताओ? ये होता है PD upon, tell me, PD upon 2T. In case of what? In case of thin pressure vessel. And if you talk about stress is like that also, so this is called longitudinal. You know, longitudinal will act only when if cylinder is closed. Suppose if cylinder will be the open na, in that case will not get longitudinal. अगर मैं उसको खोल दूं, क्रॉस सेक्शन को खोल दूं, तो नो स्ट्रेस विल गेट, क्योंकि कुछ तो है ही नहीं. In that case only will get the hoop or circumferential. But if you know, in that case, if we talk about longitudinal will be PD upon 40. तो इस पे भी क्वेश्चन आएगा, इसको याद रख लो आप. Numerical they may ask, nothing need to worry. So what will be answer? In that case, Chennai. Yes, Chennai is the right answer. Question number 13. Okay, come to the next question. Yes, what will be that? Pressure vessel are made up of. किससे बनता है pressure vessel? Pressure vessel are made of non-ferrous material, sheet metal. Yeah, thickness is very less, na? Thickness is less, so they are going to make the sheet metal. You know, because thickness is less, na? So obviously it is going to made by the sheet metal. Like that way, they may ask the question. So answer that. Yes, that is the next question on the screen. Try to solve that question. Little bit I am going to zoom out. A cantilever beam of rectangular cross section is subjected to a concentrated load at free end. Okay, sir. The state of stress at a point P on centroidal longitudinal axis of beam is given by, and some option you have. Lifeline use mat karo. No need to use the lifeline. You have to give the answer in a single time. Do not wait for the lifeline. Okay. See, a cantilever beam of rectangular cross section. Okay. Subjected to concentrated load at its free end. So, sir, this is scenario something like that, sir. Like that, na, sir? Huh? And it is going to be subjected concentrated load at the free end, sir. Like that, sir. Okay. The state of stress at a point P on centroidal longitudinal axis. Which axis they talk about? Centroidal longitudinal. So this is centroidal axis, sir. Yes, sir. So on this given by, and some option you have. What will be answer? This is moderate question, not a difficult. This question is just a moderate. So don't think this is difficult and I will leave. No. What answer I am getting? Question number 15. Kumari is going to be given answer Chennai. After that they have changed to option Apple. Okay. Tell me everyone, Baba. Tell me what will be the answer of that. So, people going to give the A for apple. A for apple is the wrong answer. This is your first lifeline. A for apple is the wrong answer. Okay, sir. Okay, what about next? C for Chennai. Another lifeline you have used it. C for Chennai is a wrong answer. Now, कितना लाइफलाइन लोगे जी? हाँ, कितना लाइफलाइन लोगे? Yes. What option left? Okay, B. B for Bombay is a wrong answer. Yes, sir. अब तो हम आंसर लगा देंगे, सर. अब तो हम आंसर लगा देंगे. Correct answer है D. Now the question is that why D, sir? Why D, my dear friends? Why D? Listen, listen. Tell me anything, yaar. Why you are making the mistake in that type of question? Really, you need more attention, okay? Like that. अगर मैं ऐसे लगाता हूँ, सुनो बात, ऐसे कुछ भी लगाओ, तो सिनेरियो कैसे होगा भाई? पहले तो ये ऐसा था, ये लॉन्गिट्यूडनल एक्सिस था, है ना? अगर तुम ऐसे करोगे, तो कहानी कुछ ऐसा होगा, ये थोड़ा ऐसे हो जाएगा, और ये थोड़ा ऐसे हो जाएगा. ये टेंशन है, ये कंप्रेशन है. नो मैं क्वेश्चन, टेंशन से कंप्रेशन जा रहा हूं, कहीं तो जीरो हुआ होगा सर, कहीं तो जीरो हुआ होगा. इफ आई एम गोइंग टेंशन टू कंप्रेशन, समवेयर देयर विल बी जीरो. यस सर, the point, the axis on which the stress is zero, that is called centroidal axis. Okay, sir. That means somewhere this is centroidal axis. Now tell me, what is the stress on the centroidal? This is tension, sir. This is compression. What about centroidal? Zero, sir. Zero. No stress. No normal stress on that, sir. No normal stress, sir. No normal stress on that, no, sir. No normal stress. Yes, sir. No normal. But, sir, do you know what will be the, torsional shear stress? It is maximum at the center. If you talk about torsional, so it will be the maximum at what, my dear friends? Center, na? It will be maximum at the center. So only I will get the shear stress, sir. Only I will get the shear stress. I will not get any normal stress. Now see the diagram. Now see the diagram, dear. See the diagram, sir. Sir, normal stress is there, sir, cannot be. Sir, normal stress cannot be. Sir, normal shear both cannot be. Only one option is left, which is right. Right or no? Huh? Right or no? सिंपल इस टाइप से आपका आंसर आ जाएगा. डी राइट आंसर था. आई डोंट थिंक इसमें भी कोई है ना. न्यूट्रल एक्सिस मैक्सिमम. यस. Okay, good. So that as a moderator, don't think that is a tough question. I will skip. No, no, no. That is the question that you must have to be solved. If you want to select in the exam, if you skip the question, as I used to say, exam will skip you. Okay, sir, that is the next question. A solid shaft can resist a bending moment of 3 kilonewton meter and the twisting moment of 4 kilonewton together. The maximum torque can be transmitted. That is easy question. Yes, that is easy. And I think now every one of you can answer. What will be answer? Answer. What will be? Everyone? Okay. Okay. That time all have given right answer. The maximum torque na. So simply we can say root under of m square plus of t square, right? Yes. So 3 and 9, 16. Yes. That, so yeah, some easy question will be there. No need to worry. But you cannot get selected only solving by the easy question. That also you have to be keep in mind. Yes, for a round shaft subjected to pure torsion, the shear stress at the center. I think now you can answer that question. Now you can answer that question. I think everyone, for a round shaft subjected to pure torsion is there, right? The shear stress at the center, what will be? Have you remember? T by J, G theta by L, tau by R, right? Pure torsion. So what say? So we can say tau will be equal to, sir, shear stress will be T by R upon J, right, sir? And the, if you talk about what will be the answer? Yes, that time again you have given the right answer. So pure shear case, simple, R will be 0, will get the 0. So C for Chennai is the right answer. And good thing is that all of you have given the correct answer of that question also. Yes, now again you are able to solve that question. A twisting moment T and a bending moment M are acting on a circular shaft. Okay, what is the ratio of maximum shear stress to maximum bending moment? What will be answer of that question? Yes, everyone. D for Delhi. Okay, what about others? All are going with D for Delhi. Okay, Alak. Okay, write down question number. DK. Twisting moment T, bending moment M, acting on a circular shaft. What is the ratio of maximum? What is the maximum shear stress? Just now you have seen tau max 16 T upon pi dq, right, sir? Simple question, yes. And what is bending moment maximum? How it is coming, I will prove in the class. Don't worry. This is 32 m upon pi dq, right? So what is the ratio of maximum shear stress? You have to be calculate tau max upon sigma b max. That you have to be calculate 16 T pi dq into 32 m pi dq. So this so yes, T by 2 m you are getting. So D for Delhi is the right answer. Yes, that is easy question. But don't think, sir, I will get selected just by solving easy question. Never. That is the next question. Okay, for a long cylinder column, uniform cross section, the ratio of critical buckling load for the case with both and clamp to the case both and hinge, and yes you have some option. क्या हो जाएगा इसका आंसर? क्वेश्चन नंबर 19 ऑन योर स्क्रीन. क्वेश्चन नंबर 19. Yes. 18. Question number 19 now. Yes, yes. Usually whenever I will come, one question will expect from the column. There was in all the year in 17 and 20, both the year question has been asked from the column. So we will expect the question from the column in 2026 also. In 2026 also we will get. So I am getting answer. Okay. Bombay, Chennai, I will come here. My dear friends, before coming to that question, I want to tell you, please remember that value. First remember that value always. अभी इसको याद कर लो भाई, बाद के लिए मत छोड़ो. Always I will come with that because one question is going to ask from that. Now remember that when both end is fixed L by 2, both end is hinge L, one fixed, one hinge L by 2, one fixed, other free, it will be the effective length will be the 2L. Now can you tell me what do you mean by effective length? तो मुझे कमेंट करके बताओ. Tell me what do you mean by effective length? What that indicate? First tell me what it. क्या है ये? First comment that. Then I will come. So in this question, both end fixed, it will be L by 2 effective length, hinge L, one hinge, other fixed L by root 2, and one fixed, other free. Whenever 2F will come fixed and free, it will be the 2L. Right? Now my dear friends, put that value here. You know, ratio of critical buckling, it is given by pi squared EI upon LE squared in case of clamp, or pi squared EI upon LE squared in case of hinge. So what will be L effective? L effective in case of clamp, L by 2, both side hinge now L by 2. Clamp, and when hinge, it will be pi squared EI upon L squared. Now just take their ratio, and by that ratio you will getting how much? The answer is coming out to be 4. How many answer have given 4? How many of you have given the 4? Chennai, yes. Clamped. What is the meaning of clamped? Clamp means, my dear friends, both end is fixed. Clamp means it is a filling. I am going to clamp, so it is fixed like that. In different way they have given. Either they can say the both hand, fixed, but they have given clamped. Clamped means fixed. They are fixed. This is clamped, so meaning is that it is a fixed. So in different way they are going to be, just frame the question like that. Okay, that is the PYQ of 2017. 2017 that question has been asked. Slenderness ratio of a column is defined as the ratio of its length to it. What will be answer? Answer everyone. Slenderness ratio of a column is defined as ratio of its length to its what? Question number 20 on your screen. List radius of gyration. Good. So now tell me, what do you mean by radius of gyration? Okay, your answer is right. But what do you mean by radius of gyration? What is the physical meaning? Can you tell me? What is the physical? What they indicate? What it indicate? What it indicate? Tell me. I know you will not tell. Still, I am hoping. I am positive people. I think you will answer. But even I also know you are not going to be answer. But okay. Positive सोचने में जा क्या रहा है? Right? So slenderness ratio is effective length. Okay, now tell me where you are going to use the slenderness ratio, especially in case of either column is long or short column. In that case, you are going to use that concept. Okay, I think this is again you are able to answer. The buckling load of a column, pin. Pin means what? Pin means what? Pin. Pin means hinge. That is the pin. That is pin. So this is hinge. They can rotate, but they cannot go up and down, left and right. Hinge means pin joint, right? Both end, okay. The buckling of the column, pin and both the end is 10 kilonewton, okay. If the end are fixed, means clamp, okay. then the buckling load change to. What will be answer of that question? What will be answer of that question? 21. Waiting for your answer. See, समझते हो load? This is L square, P, pi square, pi EI minimum upon LE square, effective length of a square. So just calculate this. Pi square here, L is effective length. So P is inversely proportional to 1 upon LE. Right? Now see, we can say here LE1 upon LE2. So in the case of when it is going to be clamp, it will be L by 2. And it was, see here, when it was pinch both the end, it was L. So from there, we'll get answer is how much? 40. How much the answer is coming out to be? 40. Okay, 40 simple na. Here, na. Right? Simple na. Here we can say PE1, in that case P1 L by 2, and just put the effective and we'll get the answer. That is the next question. Okay, that is the next question from the deflection. The simple supported beam A, length L, carry a central point load W. Another beam E is loaded with the uniformly distributed load such that total load on the beam is W. The ratio of maximum deflection between beam A and B. This is B. Okay. What will be the ratio? What will be the ratio in that case? Tell me. You have a simply supported beam, right? Two beam you have like that way. Carry central point load W. This is beam A and another beam B with uniformly distributed load. Scenario is same. Okay. This is beam B and now the scenario is like UDL. Okay. So the question is going to be asked total load W. Okay. The ratio of maximum deflection between these two. So Pandey is telling B. Let me check the answer. Yes, Pandey, you are right in that case. WL is Q upon 48 Ti, simply supported beam with a point load, and 5 WL ke power 4 upon 384 EI, simply supported beam with uniformly distributed load. Now W is equal to total W is there. So what will be total W? W into L, effective load, load per unit length into total length. Now just take their ratio and it is coming out to be what? 8 upon 5. Yes, that time slowly you are going to give the right answer. That is a good thing. Okay, dear. Now come to the next question. That is the next question. Yes. Now, two simply supported beam A and B of same width and depth and same material carry constant central load W at center. Okay. The span of B is double that of beam A. Okay. Span means length are going to be double. The deflection of beam B compared to beam A will be. That is another question from the deflection. That is the another question from the deflection. What will be answer? Waiting for your answer, dear. Yes, still waiting. Question number 23rd. What will be answer? Waiting your answer, tell me. Yes, 8 times. Pandeyji. Pandeyji is telling 8 times. Okay, what about others? 1 8. B for 8 times. Okay. See, two simply supported beam A and B, same breadth, same depth, everything is same material. Constant central load W. एक में ना यहाँ पे देखो लाइक दैट है, ओके, एल लेंथ है और यहाँ पे डब्ल्यू लग रहा है, दैट इज ए, ड्रॉ द सिनेरियो इज लाइक दैट। यहाँ पे 2L है, load is still going to be at W. So the deflection of beam B compared to, you have to be calculate deflection in case of B with respect to deflection in A. Means you have to be calculate deflection of B upon deflection of A. That thing you have to be calculate. Have you remembered the value? Have you remembered? You have forget. So just now you have seen this is WLQ upon 48 EI. So deflection is proportional to LQ. If rest thing is constant, W is same, material is same, width and height, width and depth is also same. So I will be the same, all are same. So L, so just not do no baba. So we can say simple, del upon LQ equal to constant. So we can say del 1 upon L1 ke power q is equal to del 2 upon L2 ke power q. No, just so what the relation you have to be calculate A upon B, just put the value and it is coming out to be 8. Yes, मैंने बताया ना, there is one WhatsApp channel given in the description, right? Here we can join and I will share the PDF there, and not even only that PDF, regarding your exam, whatever branch is there, all the subject question I am going to be share. That is free. You don't have to pay, okay? Free. You can judge, okay, what type of question is coming, how to improve like that way. So answer 8 is there and given the right answer. That is the next question. As per maximum shear stress theory of failure, okay, the relation between yield strength in shear tau y and yield strength in the tension sigma t. What will be answer? मिल जाएगा डिस्क्रिप्शन में यार, आई थिंक विल गेट द लिंक इन द डिस्क्रिप्शन, राइट, मिल जाएगा. Okay, what will be maximum shear stress theory? This is now maximum shear stress theory applicable good for the ductile material, and according to that theory, shear stress is equal to 0.5 times of the that, okay, yield strength. Always keep in mind, one question also you will expect from the theory of failure. One question we will expect. Either they will ask some numericals or theory. Usually they will ask theory from the theory of failure. Usually they are going to be asked like that way. Right? Okay. So my dear friends, this is the next question on your screen. Which of the following theory of failure not suitable for the ductile? Not suitable. Yes, not suitable it is going to be asked. Yes, what will be answer? Not suitable. Talk about maximum shear stress, maximum principal strain, maximum total strain, maximum principal stress. Yes, this is called Rankine theory also, right? And this is applicable in case of brittle material. This is applicable in case of brittle material, okay? So, not applicable, D for Delhi will be the right answer. Okay, that is applicable for the brittle material. So my dear friends, that all about the 25 question. So you have seen the all type of questions, some easy question, some moderate question, little bit difficult question is also there. So in the exam, you will expect the same, degree of difficulty of the question. And I have came with the question just by analyzing your PYQ, previous year question. On that base, I have came with that question. So your preparation, still I think you have more than 2 months, more than at least we can expect, okay? So, and your target must be to get a safer zone. You are a general candidate, is 160 plus minimum I talk about. For safe zone, it must be more than that, okay? So 160 you are getting. For that case, your tendency have, sir, I have to be solve all type of question. Don't think I will skip that question, that question. Initial stage, try to solve all type of question in less time. For that, practice is needed. For that purpose, I am going to give some PDF in free WhatsApp group. Here we can also practice. Otherwise, you can join our paid batch also. No problem is there. We will do a lot of practice. And yes, test series is most important. Also, practice is most important. That's why you need one best mentor in that. Okay. And rest, as I have told you, you can say, sir, where I will join the group. Here we can see now. So from there, just a scan of your respective batch will get the join from there. मैं कुछ देर के लिए छोड़ देता हूं. Now that all about the today's session, my dear friends. Anyone have any doubt, we can ask. Otherwise, thanks a lot to watching whole the session. Okay. Anyone have any other doubt? No doubt. Okay, dear friends, thank you. Good night and good luck. Fill the form faster because, as you know, 11th of the June is the last date. And one more thing, if you are going to make any OBC certificate, that must be after the 1st of April. You know, if you are from the OBC category and even in EWS, I am sure about the OBC, your OBC certificate NCL must be after the 1st of April onward. If you don't have, do that fast. Otherwise, it will not be considered there. So, जो भी document है necessary बना लो and form fill करो, and we can continue your preparation with YourPedia team. Okay, my dear friends, thank you. Good luck to all. Thank you all.